Welcome pre-calculus students. Today we're going to be looking at the free response problem from our last unit exam, that is the Unit 1 functional analysis. The purpose of this video is for you to get an idea and review the process of solving this problem here. So my suggestion to you will be to, at this time, just pause the video, grab yourself a piece of paper and a pencil, and once you're ready, you could come back and copy notes from this video. Okay, well, let's get started. Let's read the problem. Let's see what we are asked to do, and let's go ahead and solve the problem. A carpenter needs to create a semicircular opening along one side of a square wall, which is 10 meters long on each side. And we're given this diagram here. We have a 10 by 10 square, which has a semicircular piece that is being cut off from the square. Moving on, it says, if x represents the radius of the semicircular hole, answer the following questions. Okay, so I'm going to dive right in. Let's do part A, and let's see how we do it. If the radius of the semicircular hole is 3 meters, let's jump right in. Let's solve part A. In part A, it says, if the radius of the semicircular hole is 3 meters, how much material remains after the hole has been created? Well, in order for us to solve this problem, we need to realize that all it is it's asking us to do is to actually find the area once a circular piece has been removed. So I'm going to call that the total area. I'm going to assign a T as the mark for that. And in order for me to figure out what the area that is remaining, I'm going to use the entire area, the area of the square piece, and I'm going to subtract the area of the semicircle. Okay, so I'm using the area of the square minus the area of the semicircle. Well, in this particular problem, I know that we have a 10 by 10 piece of wood or material in this case, so the area in this case is going to be 10 by 10, and we are going to subtract the area of the semicircle. Now, I know that from geometry, I know that the area of the semicircle is pi times its radius, which in this case we have a radius of 3 meters. That's what's given in the problem. So pi times the radius square, or pi times 3 square, divided by 2, remember, because it's only half of the circle that we're interested in. Okay, and this is sufficient information for us to solve this problem. Now, multiplying 10 by 10 gives us 100 minus 3 squared, which is 9, so 9 pi over 2. And if you plug that into your calculators, you will see that you get an approximate answer of 85.862 meters square. Okay, very important that from now on in pre-calculus we are using 3 decimals approximation for our answer, and any answer 85.861 or 85.863 would also be acceptable answers. Okay, but don't forget to include the units, which I gather from the problem, since we have a 10 by 10 meters piece of wood. Okay, now we're ready to move to part B. Okay, so let me just scroll down a little bit. Part B is asking us, or says, to write an algebraic expression for a of x. Okay, so they want me to write an algebraic expression, a of x. So let me write it down. Which represents the amount of material which remains after the semicircular hole has been created. Okay, well, this is the same problem that we just did in disguise. Okay, if I want to find the amount of material that remains, again, I'm going to find the area of the square minus the area of the semicircle. Okay, well, again, the area of the square, since it's a 10 by 10, so it's going to be 10 multiplied by 10, minus the area of the semicircle. Now the only difference is, I know that the area of a semicircle is pi r square. In this case, we are calling the radius, and the radius here is called x, right? X represents the area, that represents the radius, so pi times x squared divided by 2. And this is enough. This is enough for me to, this will be the answer. I'm just going to go ahead and simplify the 10 by 10 to give me 100 minus pi times x squared over 2. And that's what I'm going to write as my solution for this expression, a of x. Okay, so a of x is going to be 100 minus pi x squared, and that is all that is asking me to do. Okay, so in the next part I'm going to do problems, the remaining problems, C through